Prove that if a and d are positive integers and q and r are integers such that a equals dq plus r and 0 is less than r is less than d, then negative a equals d times negative q plus 1 plus d minus r, and 0 is less than d minus r, which is less than d. Okay, so we know that a equals dq plus r and 0 is less than r is less than d. So these are our assumptions. From the second inequality, we can subtract r from each side from the left, middle, and right portion of this inequality. We can subtract r from everything to get negative r is less than 0, which is less than d minus r. So from here, we get that 0 is less than d minus r, which is part of what we needed to show here. Now, since r is greater than 0, that means subtracting r from the value of d decreases the value of d, which means that if we want to make this number bigger, we can just decide to not subtract r, and we would end up getting a bigger number. And so here's how we get the entire inequality. 0 is less than d minus r, which is less than d. Next, we're going to take this other equation and try to get the second relationship that we need to develop. Now, if you notice, the left-hand side is minus a, so I'm going to multiply both sides by negative 1 to get negative a equals negative d times q minus r. Now, this isn't quite what we wanted. We need this term, for example, to be d minus r. And so what I'm going to do is I'm going to add and subtract d on the right-hand side and rewrite this as negative a equals negative d times q minus d, and then plus d minus r. So here I just reordered the terms on the right-hand side. The last step we need to do is we need to factor out a d and write this as negative q minus 1, and then plus everything else, which is d minus r. And that's the other relationship that we wanted to show. So that answers part A. Part B says, indicate how to modify algorithm 4.10.1 to allow for the input a to be negative. So we need to modify this algorithm specifically so that we allow a to be negative. Well, if a is negative, then negative a would be positive. What we can do is we can define this algorithm to be if a is positive. We can have a separate algorithm for when a is negative. The key difference here is that my remainder r needs to be redefined as negative a mod b, which gives us a special remainder d minus r. And so we just have to make these adjustments according to part A. Thanks, everyone, and I'll see you in the next video.